All right, let's begin.
That moment when you realize you gave too many examples. It's going to take forever. Shouldn't take forever. We should be able to get through these relatively quickly. Now the first one, as I mentioned last time, that's actually something you should know by heart. But let's actually derive it. Let's say hell freezes over and you're in an alternate universe. How do you figure out that that's actually the arctangent of x plus c? You can actually figure that out with a trig substitution. 1 plus x squared. What do you think would be the correct trig substitution here? Yeah?
Are we using x equals a tan theta, or no?
Okay. But
Or just, tan theta?
right, because a is 1 in this case.
Yeah.
That's like a 1 squared, so it's just tan theta.
And dx would be secant squared theta d theta.
And you just go and you plug these all in. So you'd have 1 over 1 plus tan squared. Your dx would be secant squared theta d theta. Of course, 1 plus tangent squared is secant squared. So those guys cancel, so you just have the integral of d theta. What's the integral of 1 d theta?
Theta plus
Just
c.
theta. Theta plus c. And what is theta? Well, if your x is tangent theta, then your theta must be the tan inverse. So quick derivation there. Of course, in Calc 1, where we did this, the derivation was quite different. We used the we actually figured out what the derivative of this was 1 over 1 plus x squared, and then we just took the reverse as an integral formula. But here's how you can directly figure out the integration. Trig substitution. D. Now again, I'm not always going to emphasize this when I'm going through, but again, you do want to be thinking in a certain way here. Right? So try to apply a basic rule. If not, can I simplify to apply a basic rule? If not, will the substitution work? If not, then you think of something more sophisticated like a trig substitution or something, or an integration by parts or something harder than that. So here we're jumping to trig substitution, but it's assumed that you'd have went through a thought process to arrive at the conclusion that I want to use a trig substitution, and when you're ready to use a trig substitution, you're supposed to then know how to actually apply it. So what would be the correct trig substitution here? So x would be
X equals root 3 secant theta.
radical 3 secant theta. Because that reminds you of secant squared minus 1, which you know is tangent squared. So your dx would be? What is dx?
Root 3
Secant
theta.
theta.
Secant theta, tangent theta, d theta. Now you literally go and you swap these all in. So our integral is going to become 1 over x squared, which is 3 secant squared theta, times the radical of 3 secant squared theta minus 3, times your dx, which is radical 3 secant theta, tangent theta, d theta. You end up with that whole thing. Now, of course, secant squared minus 1 is tangent squared, so under the radical here I have 3 tangent squared, and I can actually just replace that with radical 3 tan theta. And here we have radical 3 secant theta tan theta. Theta. How do you do that? Yeah?
Can you, never mind.
Wait, sorry.
Yeah.
How do we get to tan theta again? Sorry.
Sorry, don't apologize for asking questions. This part here, this is 3 times secant squared minus 1. Secant squared minus 1 is tangent squared.
Oh, sorry. I didn't
Take
see
the
that.
radical of that.
I got it's just identity.
Yeah, so trig identity, Pythagorean identity. How do we continue? Yeah.
You can cancel a bunch of
You
stuff.
can simplify, radical 3's cancel, tangents cancel, the secant cancels with one of the secants here, and we have 1/3 times 1 over secant
Which
theta.
is the same as cosine.
Which is, that's cosine.
Which is sine.
Which is positive sine theta plus c. How do we get the answer in terms of x's?
Let's draw a right triangle.
Draw the right triangle. So for here, we're going to draw up that right triangle. How do we create it?
So secant, secant theta is x over root 3.
Right, so secant theta is x over radical 3.
So secant is what? Hypotenuse over adjacent.
Hypotenuse over adjacent, which means the hypotenuse is x and the adjacent is radical 3. Pythagoras' theorem is going to tell you that this is going to be the radical of that squared minus that squared. And from that now we can find what the sine of theta is. Sine is opposite over hypotenuse. So your sine is that. Go here, so our final answer is the radical of x squared minus 3 all over 3x. Let's see, that's hard. Yeah.
We don't really need to do the top part, because if you just know the triangle, then you're fine, right?
Starting from where?
We didn't need to do secant theta equals x over square root of theta, right? X over radical 3, right?
Well, the reason why I did that is to know how to draw the triangle. I mean, if for some reason you memorize the triangles by some other way, then no. But
Okay.
I did this because of SOHCAHTOA is going to tell me what to fill in for the sides of the triangle.
Okay.
But there are other ways. You could use this identity to figure out what the cosine is, and then use cosine squared plus sine squared equals 1 to figure out what the cosine is. You could do it purely as a formulaic basis, but I feel like drawing a picture in SOHCAHTOA is easier
Alright.
psychologically.
Alright.
What'd you do for this one? Yeah?
Convert it to x plus 2 square plus 4.
Right, complete the square. So, complete the square. I do expect you to know how to do that. So that's something from algebra class. So, should be able to figure out that this is x plus 2 all squared. Which when you expand, that's x squared plus 4x plus 4. And then to get to the plus 8, we need to add an additional 4. So by completing the square, we get that. Now what?
Set x.
Yeah, go, continue.
Set x plus 2 equals.
Now that is like your x in the general trig substitution form.
Theta.
So you said x plus 2 equals
10 theta.
2 tan
Oh,
theta.
2 theta.
Right, because in that case, this part is your a squared, which is 2 squared. So that's going to be your tan theta. Differentiate both sides. Your dx is equal to 2 secant squared theta d theta. And now you plug in everything. Now of course when I plug in this here, that's going to give me a 4 tangent squared plus 4, which I can factor out the 4, that leaves me over the secant squared, so this all becomes 2 secant theta in the denominator. My dx becomes 2 secant squared theta. This cancels with that. It's the integral of secant. What's the integral of secant?
ln secant theta, absolute secant theta. I got jumbled up on it. Yeah, that.
So that's gonna. Congratulations, Jhevon. Okay. How do we get the answer in terms of x's?
Draw a triangle.
Draw the triangle. What do we use to figure out how to draw the triangle?
Tan theta is x plus 2 over 2.
You realize that tangent of theta is x plus 2 all over 2. That's going to be your opposite over adjacent. And so here, I can draw the triangle. My opposite is x plus 2. My adjacent is 2, which means Pythagoras' theorem. This is going to be the radical of that squared plus that squared, which is actually just x squared plus 4x plus 8. It's going to be that guy. And so from this, I can figure out that my secant, which is going to be hypotenuse over adjacent, is going to be the radical of this, x squared plus 4x plus 8 all over 2. And my tangent, which I can actually I just found from here, so for that tangent, it's x plus 2 all over 2. So I'm just going to actually plug that in. ln of plus and that would be the answer. Now, by the way, or if this were the textbook and you look in the back of the book, it's very unlikely that they'll write the answer in this form. They would actually write the answer like this. Now, why would that be okay? So you did that, you got that answer, you look in the back of the textbook, you see that answer, and like, there's no division by 2. Did I do something wrong? Yeah.
If you divide by 2, that can be written as minus 1 2, and then that.
Right, so
That's,
remember that ln of A over B is just ln of A minus ln of B. So if you have the ln of the radical x squared plus 4x plus 8 plus x plus 2, that's all over 2. You'd be able to write that as ln of, all that gibberish for the radical, minus ln of 2 plus c, but then that ln of 2 part is just a new plus c, right? So just be aware of things like that. They might apply log rules when writing down the answers, just to get it a little bit simpler. Yeah.
When we substituted it back in,
Yes.
where did the plus 4 go again? So we,
Here. My x plus 2 is 2 tan theta, so this would be 4 tangent squared theta plus 4.
oh, then we factored out the
Factor out the 4. Tan squared plus 1 is secant squared. Then I take the radical of that, so I just get
I see, so
yeah. It's always going to be me applying some trig identity to simplify things. In fact, when we were doing, when I was setting up the trig substitution, and I said, there's always an identity in the back of my mind that I'm trying to make it look like. So it's either going to be 1 minus sine squared, or I want it to look like 1 plus tangent squared, or I want it to look like secant squared plus 1, because 1 plus tangent squared will always collapse into a secant squared. So I can just replace all of this with a single secant, is the idea. Like we chose it to make that happen. So that would be the answer for that. And that was C. Yeah.
You said 2x equal to tangent theta, tan theta.
Right, because here, you just think of this as 2x all squared plus 1 squared. So your x is actually 2x and your a is actually 1. That looks like a trig substitution in the form 2x would be 1 tangent theta. This would mean that 2 dx is equal to secant squared theta d theta. Or your dx would actually be 1/2 secant squared theta d theta. So you go and you start to plug this in. So you have 1/2 secant squared theta d theta over, and again, once I plug in my 2x here, it becomes a tangent squared plus 1, which is a secant squared. We're going to take the radical, so that becomes a secant in the denominator. And this cancels that. So we have 1/2 the integral of secant tangent C. And again, you're going to do the back substitution. Here, we know that our tangent of theta is equal to 2x. You think of it as 2x over 1. That's going to be your opposite over adjacent. That means I can draw a triangle with theta here. The opposite is 2x. The adjacent is 1. This would be the radical of the sum of the squares. So then my secant would be equal to hypotenuse over adjacent, 4x squared plus 1. So this would be 1/2 ln of 4x squared plus 1 plus tangent, which is 2x. Is that it? Questions on that one?
So you don't need a half, right? Because it just.
I don't need the half? Where?
When like in the final answer, you need the half.
This half?
Yeah.
Yeah. Yes. If it was like a plus a half, I wouldn't need that.
Okay.
Yeah.
Sorry, can you just go over where you got each substitution from? I get the dx is 1/2 secant squared d theta and the flip side of y is the next part. Yeah.
Oh, this part here. This is the radical of 4x squared plus 1, which is the radical of 2x squared plus 1. I made the substitution 2x is equal to tangent, so this 2x squared is just tangent squared plus 1. Tangent squared plus 1 is secant squared. Secant squared, this cancels that to give me the secant. It's that one. Let's keep going. That was D, E. So without that 3/2 power, that's just the arc tangent, but with that 3/2 power, things are going to change a little bit. What substitution would work here?
X equals tan theta.
X equals tan theta, which means you can think of this as x over 1. So for future reference, that's going to be my opposite over adjacent. Now, this means that your dx is going to be the derivative of tangent secant squared theta d theta, and we're going to get secant squared theta d theta over. So my x is tangent, plug it in there, I get tangent squared plus 1. That's my secant squared theta over 3/2. The 2's would cancel here, and so that's just secant squared over secant cubed. And that's just the cosine. Integral of that is positive sine. And positive sine this, draw the triangle. Opposite is x, adjacent is 1, so this is going to be the square root of x squared plus 1. So our sine of theta is opposite over hypotenuse.
Is it always gonna end up at the missing side?
It's going to look like the,
Yeah.
yes, it's going to look like the x squared minus plus a squared, or the x squared minus a squared, or the a squared minus a squared, yes, with a radical. So yes. Equals, so x over the radical of x squared plus 1 plus that's not. F. Now at this point, you really want to be practicing each technique until, again, it becomes second nature. And then when it gets closer to the test, what you want to start practicing is how do you recognize when to choose which technique if you have a variety of integrals. How do you choose? That's going to be the harder part in the end, hopefully. But we can get around it. So a trig substitution can work here. What is the substitution?
X equals root 3 secant theta.
So dx is going to be radical 3 secant theta tangent theta d theta. And now I'm going to do something. Now, one thing you'd realize with trig substitution, I mean, some of you might not find it so, I mean, these examples aren't too crazy, but this little situation over here is kind of annoying to actually get through. So what I would say is if you're given a definite integral for a where you would do a trig sub, I would always just change the limits as opposed to changing back to x and then plugging in the x values. So always change the limits for a trig sub with definite. It will save you some time, right? It's not a dictatorship, that's a recommendation, but I take it seriously. It's like if it's a trig sub and there's a definite integral, I'm definitely going to change the limits. So probably I'll get that out of the way first. I realize that if x equals 2, that means I have 2 is equal to radical 3 secant theta. This means that your secant theta is equal to 2 over radical 3. This means that your theta would be what? So saying that secant theta is 2 over radical 3 is the same as saying cosine of theta is radical 3 over 2. Where is the cosine of radical 3 over 2?
Oh, isn't it 30 or 60?
30 or 60? Yeah, which one?
It's one of those.
No, it's 30. It's pi over 3.
Pi over 6.
That's what I think.
I mean, if any of you are going into engineering, I guess you can start to think in degrees, but if you're a math student, you want to think in radians. So pi over 6 would be what I would change the upper limit to. And if my x is equal to radical 3, this means I can plug in radical 3 to my substitution. Remember, you use the substitution equation to change the limits. So radical 3 would equal to radical 3 secant theta. This means that your secant theta equals 1, which means that your cosine of theta equals 1. Where is cosine equal 1?
0.
So I'm going to change these and then change the limits. The lower limit I'm going to change to 0, the upper limit I'm going to change to pi over 6. And that would save me from having to do that triangle thing later on. I won't have to do a back substitution. I'm just going to plug in these new numbers. So now the integral is going to become the integral from 0 to pi over 6. Here. New limits. And of course I plug in radical 3 secant here. That's going to give me 3 secant squared minus 3. That's going to give me radical 3 tangent times the dx. My dx is radical 3 secant theta tangent theta d theta over my x is radical 3 secant theta. So radical 3's cancel, my secant theta cancels with secant theta. So this is 0 to pi over 6 of tangent squared with a radical 3 pulled out. Tangent square theta d theta. How do we integrate tangent squared?
Use an identity or no?
Are you asking me? What do you think?
1 minus, wait, no.
Yeah?
If you change it to secant squared theta minus 1, and then when you integrate it, it's tan theta plus theta plus c.
Tan
Or
theta
minus theta.
minus theta. Now it's not plus c, it's definite, so I'm going to plug in pi over 6 and 0. So that's going to be radical 3. I do have to change it back to x's because I changed the limits. That's going to be tangent of pi over 6 minus pi over 6 minus, open parentheses, tangent of 0 minus 0. Now of course tangent of 0 is 0, you should remember that. 0 is of course 0, so you're not subtracting anything. So here we have radical 3. What is the tangent of pi over 6?
3 over 3.
That's fancy. So for definite integrals, if you realize that you have to do a trig sub, I pretty much always change the limits. It'll actually save you some time. I mean, otherwise it's pretty much optional. G, knocking these off. Okay. 1 over the radical of minus x squared minus 4x x. You do that one. Yeah.
Do you factor out -1?
Now we're not going to completely factor out that -1 because that'll give us the square root of -1, which is going to give us a complex number, which we're not doing that in this class. So we'll worry about complex numbers later on. For now, yeah.
Complete the square.
You can complete the square on the inside. So this is x plus 2 all squared. That'll give me x squared plus 4x plus 4, but there's no plus 4, so I have to subtract 4. And now I can distribute the negative sign. That'll give me a plus 4 minus x plus 2 all squared. So that original integral simplifies into that integral, and how do we continue?
X equals tan 2 tan theta. Oh wait.
x plus 2
x plus 2.
X
Two
plus
sine.
2 equals
2
For
2
sine
sine theta. And now our dx is going to be 2 cosine theta d theta. And so our integral is going to look like 1 over the radical. Plug in 2 sine theta here, so that gives me 4 cosine squared theta underneath. My dx is going to be 2 cosine theta d theta. And of course that's all cancel with that. So this is just the integral of 1 d theta, which is theta plus c. My theta is just going to be basically the sine inverse of x plus 2 over 2. This, so that's that one. This is that one. H. How do we do this one? Yeah,
So 4 minus x squared would be a squared minus x squared, so you could say x equals 2 sine theta. Then you could say dx equals 2 cosine theta d theta.
oh, so yes, we could do that. Does anyone see a better way? Yeah,
You can just use
Yeah, u equals 4 minus x squared.
better. U equals 4 minus x squared. Just do a regular u substitution. That'll get you to the answer a lot faster in general. If you want to be even faster, you can do that. So you get 2u du is equal to minus 2x dx. So you get minus u du is equal to your x dx. This part here is minus u du. And the denominator here, based on that, is going to be u. So your u's, so you have minus u divided by u, du. Just get minus 1 du. It's minus u plus c. And what is u? Well, it's the square root of 4 minus x squared plus c. Regular u substitution is better here, by far better. You can try doing a trig sub and compare, but the regular substitution is going to be nicer. What about I? So that's a trick. And doing all these trig sub one after another, I want to see if I catch you with this one. U substitution is better here. What about this one?
You can't choose u substitution in this one.
You can't?
It wouldn't work well.
Why not?
Because if you make u, in this case, you would make u equals x squared minus 3.
Yeah?
Du would be
Let's do that. So your 2u du would be 2x dx. So your u du would be your x dx.
oh well, you could take out an x, so it'd be x squared x.
Yeah, so this here, the x cubed, you can think of it as x squared times x. And your x dx is that guy. What about your x squared? X squared that's left over.
It's u squared plus 3.
You can just solve for the x squared here. U squared plus 3 is equal to my x squared. So now you start to plug this in. Get u squared plus 3 times your dx, which is u du, divided by the radical of x cubed, x squared minus 3, but that's just u squared, change the square root, that's just u, u's cancel, u cubed plus 3. So it turns out that a substitution, a regular, everyday old-fashioned calc 1 substitution works for this one too. You integrate u to the 4th over 4 plus 3u plus c, and then of course you plug in u. So your u was the square root of this guy. So that's going to be x squared minus 3 squared over 4 plus 3 times the radical of x squared minus 3 plus c. Okay. Can you think of a rule when a regular u substitution would work and when a trig substitution would be better? So here was a random assortment of integral. You go out and you have to pick, who can I do a u substitution on, who would I have to do a trig substitution on? Yeah.
So for the u substitutions, you could see that it's like a single x or x squared, x third just by itself over x squared minus something. But for the regular ones, it's like either just a constant on the top or a constant subtract something.
What if I told you this? Trig sub or u sub?
That would be using what I said, that would be u sub.
That would be a u sub?
Yeah.
U equals x squared minus 3, or you can do the u squared. 2u du would be 2x dx. And so here, I can think of this as x times x dx. So that's going to get replaced with that. And what are we going to have left over? We're going to have left over an x. The x is going to be the radical of u squared minus plus 3 times u du divided by u. And you would actually get u squared plus 3 du. How would you integrate that?
Could you make it u squared plus 3 all to the 1/2 element? No.
And then?
And then expand it, or that would be terrible.
Oh yeah, and you don't really even know how to do that. To expand that, you need an infinite number of terms. We'll talk about that later in the semester. You literally spend like all of eternity trying to expand that. How would you integrate that?
Could you do reverse power rule and then reverse like chain rule?
No, substitution is the reverse. That's what substitution is. Yeah? What would you do?
If you see the under the root, if that's x squared, then that will become x, and then if the upper one divides the lower one, that if that number is even, then you can use the u substitution.
Okay, so trig sub versus regular sub. How do you know when to choose which? I would also suggest that this one is preferred. So if you're in a situation where either one can work, it's preferable to get the regular substitution to work than the trig substitution. Because you don't need to have a whole triangle and you don't need to remember all your trig identities and trig formulas. That's just an added layer of complication, right? So if you're in a situation where either a trig sub or a u substitution can work, it's better that you go to the u sub. It will, I can just mention here for these two, either one could actually work. You could actually do these with trig sub. I didn't, because the u substitution way was a lot nicer. So how do you choose? So trig sub, this means if you have the expressions like an x squared plus a squared, an x squared minus a squared, or an a squared minus x squared, is when you would think of someone as, okay, this is a candidate for a trig sub. What I would say is a caveat is if there is a factor of an odd power of x elsewhere, then a regular sub can work. Okay. So you look at these two here. This looks like an a squared minus x squared. So I'm like, okay, trig sub could work on this. But look here, I have an x to the first power. 1 is an odd number. This takes effect. So I'm going to say, well, if there's an odd power, a regular substitution can work. That is preferable. So I would look at this. I would know a trig substitution could work, not preferred, regular substitution. Similarly here, you'll notice that there's an x cubed elsewhere. That's an odd power. It'll always mean then that you can factor off an x to get rid of the substitution part, the dx part, but then the x to the even power that's left over, you can use your original substitution to actually solve for the even power, right? Same thing would have happened if you had say an x to the fifth. So again, you could do your u squared equals x squared plus 4. Your 2u du would be equal to 2x dx, which u du is equal to x dx. This part, you would think of it as x to the 4th times x. So your this part, your substitution takes care of that. For the x to the 4th part, well, that's just x squared squared. You'd be able to use this equation to solve for x squared. That's just u squared plus 4 minus 4 squared. And so now you can actually just swap this out, and it's actually going to turn into u squared minus 4 all squared du with a regular substitution. It's going to be u to the 4th minus 8u squared plus 16 du, and of course it's regular power rule from so trig sub versus u sub. Look if there's an odd power of x somewhere else to help you out, and if there is, a u sub can work. If there isn't, there wasn't in this case, there wasn't in that case, there wasn't in any of these cases. I mean, here's an odd power of x, but it's in the denominator, so technically this is not what you want. You want it to probably say positive odd power. So if your odd power is in the denominator, sometimes it can work, but you might also sometimes need an additional method on top of the u substitution. So, but if there's an odd power in the numerator, then you can definitely get away with a u substitution. So I probably wouldn't waste my time with a trig substitution. So that's that. A lot of practice. So the test today is on trig substitution, the quiz today, and we'll start another integration method tomorrow.